Alright students, so here is the review question number 1 for your first pre-AP Algebra 2 test. And what you're being asked to do in this problem is find the perimeter of this shape. And so all that really means is add up all of these algebraic expressions. Okay? So we're going to do that, and I'll show you exactly how I want it done. Given the size of the test and the space that you have to work with, we're going to definitely need some scratch paper to actually do this correctly. Give me a second to turn off that. Alright. So just basically we're going to stack add. Alright, now remember to put like terms with like terms. So when we stack add, that means we're going to do like 3x squared plus 12x minus 1. All right, and then we're going to add to that x squared minus 7x plus 9. And then we're going to add to that 2x squared. And then we have no linear term, so we can put in here plus 0x, if that helps you, just so you know that there's nothing there. But then we've got a constant term at the end, minus 4. And this is going to help us keep everything lined up. So now we need a big line here to show the addition, and we're going to do this in columns. Okay, this is the best way I've ever come up with to kind of keep this organized. We're going to do this by column. Right? Okay, so we're going to start, it really doesn't matter where we start. We'll start on the left and we'll do these quadratic terms first. So one thing I like to do is whenever I have no coefficient, I write a 1. That way I know that there's something there I have to add. So 3x squared plus 1x squared plus 2x squared. 3 plus 1 plus 2 is 6. So the sum of the quadratic portion of this perimeter is 6x squared. Okay, so now we have 12x minus 7x. That's going to give us positive 5x plus 5x. Now we have negative 1 plus 9, which is 8, positive 8, and then positive 8 minus 4 gives us positive 4, so plus 4. So the perimeter of this triangle is 6x squared plus 5x plus 4. And I don't think they want us to evaluate the perimeter. Let me look. Yeah, it just wants us to add it up. So in this case, that would be the full answer. So we'll go ahead and put a red box around that. Okay, and then we'll come back here and do number 2. Okay guys, so I see I'm an idiot. So this is the area, right? This is number 3. So the thing I just did is number 3. And I'll try to order it that way in the video. So when I cut this video together, this is going to sound super confusing. But basically, I was supposed to find the perimeter first, but I computed the area. So now I'm going to compute the perimeter. But this part of the video will appear before the part of the video where I compute the area. So it's totally out of context. Enjoy the random out of context commentary. So now we're going to find the perimeter, okay? So this is a rectangle, which means that we have two sides, or a four-sided shape, and this side is equivalent to the other side because the lines are parallel, and this side is equivalent to this side, okay, and the lines are parallel. So this times 2 plus this times 2 will give us the perimeter of the shape. That's the basic idea. So let's do this, because here's all that junk I did to calculate the area. Okay, so forget about that, since that's not what we're looking at here. Instead, let's calculate the perimeter. And basically, this was number 3, and now we're going to do number 2, calculating the perimeter, which is going to be 2 open parentheses x squared minus 4x plus 2 plus 2 open parentheses 2x plus 3. Okay, so let's just go ahead and do it. The distributive property, okay, this is the distributive property. We're going to distribute this 2 all over the place. So 2 times x squared equals 2x squared. 2 times negative 4x is negative 8x. 2 times 2 is positive 4 plus 2 times 2x is 4x. And 2 times 3 is positive 6. All right, so let's highlight our common terms. Here's a common term with this term, and I spy another common term with my integer values. So I've got linear terms that can be combined here, and I've got integer values that can be combined here. So we've got this term which can't be combined with anything, and then negative 8x plus 4x is going to be minus 4x, and then 4 plus 6 is 10. So this is your perimeter right here. Perimeter, okay? There you go. That's your perimeter right there. Let's go ahead and put a box around that. And that's number 2, okay? So sorry, I did number 3 before I did number 2, but that's number 2. Now we're going to move on to number 4. All right, guys. Sorry it's taken me so long to get to this, but I'm babysitting my great niece, so you might hear the Toy Story in the background. So what we're going to do here in number 2 is find the area of this shape. Now, the way that I do it is I use a method called box. So I'll show you that method. Basically draw a shape similar to what's given to you. And then we take the ruler and we split that into 3 columns and 2 rows. And the reason we're doing that is because on the top here for the length, we've got a trinomial, 3 terms. And then on the bottom, or on the side rather, we've got a binomial. We're multiplying a trinomial by a binomial. So now I'm going to just I'm going to jot these down like this. X squared negative 4x plus 2. And then here I'm going to put 2x, and here I'm going to put plus 3. And I'm basically just going to multiply this out like it's a matrix, okay? So x squared times 2x. The thing to remember is there's a 1 in the exponent section. So if I'm doing, and here it's helpful to remember there's a 1 in the coefficient section. So if I multiply 2 times 1, the coefficient part of my product is 2. And now the bases are the same. So the product property of exponents says we add 1 plus 2 is 3. So this is going to be 2x cubed. Okay? Now I'll do the same thing on the bottom. 1 times 3 is 3. And then there's no algebraic part, right? So it's just x squared comes along for the ride. All right. So now we're on to this one, exponent of 1. So let's go ahead and multiply the coefficients. Negative 4 times positive 2 gives us negative 8. And then x to the first times x to the first gives us x to the 1 plus 1, which is x squared. Moving on, 2x times 2 is 4x. It's getting easier. Negative 4x times 3 is negative 12x. 2 times 3 is 6. So now what, right? I want you to notice a pattern. Do you notice that these terms are common? And that these terms are also common? You're always going to notice that pattern. So just keep it in mind. Let's list out the terms now in order of degree. So highest exponent first. 2x cubed. Now we combine these terms here, okay? What's negative 8x squared plus 3x squared? Well, it's going to be minus 5x squared. Now we combine these terms. Negative 12x plus 4x is negative 8x plus 6. That's the answer. Okay, so put a box around that. And move us on to number 3. Okay, looking at number 4, we see we're in a section for evaluating functions. I wanted to show this whole part here. Basically what I'm going to do is just screen clip out the number 4, okay, and just paste that sucker right here. All right, so now let's work on it. What are we being asked to do, ladies and gentlemen? Very simply, we're being asked to substitute negative 3 for n. So we're going to write out h of negative 3 equals negative 3, open parentheses, negative 3, close parentheses, squared minus 4. Okay, so that's going to equal negative 3, open parentheses. Now, squaring a negative number makes it positive, so that's going to be 9 minus 4. PEMDAS tells us to do the multiplication first, so do this first. This is negative 27 minus 4. Negative 27 minus 4 is negative 31. So h of negative 3 equals negative 31, and that's number 4. Well, let's keep rolling along. See if we can do this whole section here. Number 5, let's screen clip it so we can do it. Come on, bro. Paste. There. Okay, so again, this is an integer evaluation. It's going to be simple. F of negative 5 equals, open parentheses, negative 5, close parentheses, cubed, minus 2, open parentheses, negative 5. Okay. Well, be careful. Just remember that when you do negative 5 cubed, that's negative 5 times negative 5 times negative 5. Okay, so it's 125, but you got 3 negatives. 1, 2, 3. Okay, so because there's an odd number of negatives, the answer is going to be negative. So it's negative 125. Negative 125. And then we have negative 2 times negative 5, which is positive 10. So negative 125 plus positive 10 is negative 115. So f of negative 5 equals negative 115. I don't know if I did this for the last problem, but that's your answer right there. Did I? Nope. Let's go ahead and put a box around it. All right, moving on to number 6. We're flying through these. Okay, well, here's where we're going to put in the algebraic expression. This is where things start to actually get kind of interesting. I think we did this one in class. Anyway, I'll go fast. If we did it in class, yeah, sorry. So h of negative 4x equals, okay, open parentheses, negative 4x, close parentheses squared, minus 2, open parentheses, negative 4x, close parentheses, plus 3. She's all right. She's eating. Okay, so now, here's the deal. This has an exponent of 1. This has an exponent of 1. We're going to distribute these 2's. Okay? We'll see if I have to pause this video for a second here. All right, so anyway, we're going to distribute the 2's. So basically, I've got, instead of negative 4x squared, what I've really got is I've got negative 4 squared times x squared. Okay? Minus 2, open parentheses, negative 4x, close parentheses, plus 3. Well, negative 4 squared is just 16, and x squared is x squared, so this is 16x squared, and then we distribute the negative symbol. So negative 2 times negative 4x is positive 8x plus 3. We're done. There's nothing to like do. So just put a box around it. Well, we better write, we should have written negative 4x. H of negative 4x. Okay, now we can put a box around it. Moving on. We're moving on, ladies and gentlemen, to number 7. All right. This one is actually cool because you get to do something. So here, with the thing we're substituting in is actually like a thing, 2 plus a. It's like not an equation, but it's an expression. So P of 2 plus a equals negative, open parentheses, 2 plus a, close parentheses, minus 2. And it really helps me, because I'm not smart, to put a negative 1 right there. So I know that I'm basically distributing a negative 1 right there. That helps me. So I've got P of 2 plus a equals negative 2 minus a minus 2. And I see some like terms right here. So I'm going to say P of 2 plus a equals, and I'm going to lead with my coefficient and my algebraic term. So I'm going to put negative a, and now combine these together. Okay, negative 2 and negative 2 is minus 4. You always want to lead with the letter. That's just good practice, right? Because if you were writing a linear equation, you would want to lead with the letter and then interpret that as a slope if you were doing slope-intercept. So it's just good practice, lead with the letter. It's right if you had written negative 4 minus a, that's still, quote, right. But, you know, this is even better. Okay. Moving on, ladies and gentlemen. Let's see if we're moving on to a new section. Yeah, we are. We're going to move on to a new section. So here's what I'm going to do. We're going to stop the video here, and I'll come back in 2 seconds. Go check on the little kid in there, and we'll do 8 through 15. All right, well, we left off at number 7. Having finished number 7, we're moving on to section 8 through 15. Now, those of you paying attention to the bottom right corner of the screen will notice the huge jump in time. and I thought I would just let you know. So when you have a little tiny baby, right, like my great niece, who is 21 months old, and you feed that baby, the moment the baby is done being fed, that is the perfect opportunity to go ahead and give that baby a bath, and then go ahead and get that baby ready for bed. So that's what I've been doing since the last timestamp. So now you have some idea of how long it takes to go from feeding a child to having that child be put asleep, and then cleaning up the entire apartment so that when the baby's mama gets home from work, there's not like a huge mess here. All right, so I don't know how long that was, 2 hours, 1 hour, 90 minutes. Needless to say, folks, a child is no laughing matter. All right. Okay, so number 8. So what we're asked to do is, let's zoom in here. What we are asked to do is subtract function h from function g, and then evaluate the resulting difference at 8. Okay, so let's go ahead and clip that out and do that and see what we get. Okay, well that was huge. All right. So what we're going to do is we're going to subtract h from g. So I'm going to rewrite this because do you notice how these terms, these are the linear terms, they need to line up, right? This second equation has no quadratic term. This is a quadratic term, and this top equation has no constant term like down here. So this is just a minefield of possible errors. So instead of writing it like that, I'm gonna kind of rewrite these in a way that makes it impossible to get wrong. So first I'm gonna write 1x squared, right? You can make this, idiot proof. Not saying any of you are idiots. I'm saying me. I'm the idiot, and I need to idiot prove it for myself. Plus 4x plus 0. Okay, so I'm making sure that I'm filling in all the columns. Now over here I have 0x squared, right, minus 4x plus 4. Okay, now this is really going to lend itself to what we're about to do, because what we're about to do is we're about to draw a huge line right here, and we're going to put parentheses. This is very important. So it's asking us to subtract, right? So we're going to put parentheses here around this, and we're going to put the big subtraction sign. Now, this subtraction sign is going to need to be distributed, and I'll explain what that means. But first, I'm going to show you my little technique. Wait, I didn't draw my line. Okay, so first I'm going to draw my line right here. Okay, and now I'm going to spin this sucker 90 degrees. Come on now. Okay, now what I do is I kind of demarcate using dotted lines the columns, and I do this in pieces, and this kind of helps me keep my work straight. All right, because now it doesn't matter what order we do this in. So let's start with the left column, let's call it, okay, the quadratic column. 1x squared minus, okay, minus 0x squared. So 1x squared minus 0x squared is 1x squared. Now 4x minus 4x, right? Because that minus sign is distributed. That's the key. 4x minus 4x is plus 0x. Okay, so that term is going to disappear entirely. Now, 0 minus, right, 4. 0 minus 4 is negative 4. So remember, this term really just disappears, and this term never really existed, neither did this one, but we did it to make it simple. So here's our resulting, well, let's write it over here. So g minus h equals x squared minus 4, okay? That's what we learned just now. So now what we want to do is we want to do open parentheses g minus h of 8, which basically means we're just going to substitute in an 8 for that x right there. And we're going to get 64 minus 4, which equals 60. Right? Couldn't be easier. So g minus h of 8 equals 60. Red box of correctness. Done. Number 9 coming up. What's happening now? Okay, so now we're adding them. You know, addition is always easier because you don't have to worry about the implicit distributive property associated with subtracting. So let's go back here and paste number 9. Okay. So once again, we have a lack of quadratic term in the second function and the lack of a linear term in the first function. So it's trying to confuse you, right? I always think they're trying to get you, right? So we're going to write 2n squared. There's no linear term, so I'm going to put in plus 0n plus 1. Second row, there's no quadratic term, so I'm going to put 0n squared. And then here there's a plus 2n, and then minus 2. Now this is just addition, so this is way, way easier than subtraction. So here we're going to draw our big, huge line, and this is addition, so we're going to spin this sucker 90 degrees. And we're going to draw our dotted lines so that we don't make silly mistakes. All right, let's go. Let's add. 2n squared plus 0n squared is 2n squared. 0n plus 2n is plus 2n. 1 plus negative 2, 1 minus 2, what is that, negative 1 minus 1, okay? So we can write g, that's an 8, g plus h equals 2n squared plus 2n minus 1, right? So now we want to evaluate that at negative 8. So we're going to write open parentheses g plus h, close parentheses, of negative 8 equals 2, open parentheses, negative 8, close parentheses, squared, plus 2, open parentheses, negative 8, close parentheses, minus 1. Let's do the work. Open parentheses, g plus h, close parentheses, of negative 8 equals 2 times 64. Negative 8 squared is 64. And then negative 8 times 2 is negative 16 minus 1. That's going to be negative 17. What's 64 times 2? 128. So 128 minus 17. 128 minus 17 is it really true? 111? So g plus h of negative 8 equals 111. Bum, 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 bum. Okay. There you go. Moving on, number 10. So here we're asked to subtract f from g and then evaluate, I love this, evaluate at negative 4x. Very exciting. Okay. All right. So first things first, we're going to subtract f from g, which first thing means we got to rewrite it, right? Because now we got a whole bunch of missing terms. So I've got 1x cubed plus 0x squared minus 4x plus 0, right? So there's your cubic term, your quadratic term, your linear term, and your constant term. Now here, I've got 0x cubed plus 0x squared plus 1x minus 3. See where I'm just putting zeros in where there's nothing. So now, remember we're doing that subtraction, so there's the distributive property at every point of this. Okay, let's spin this around. Okay, now parentheses are very important right here. That's why I put them in red before. They're very importante because you're putting a huge minus sign out here, right? I want you to know that you're going to be distributing that every time. So 1x cubed minus 0x cubed is, well, in this case it doesn't matter. This is just x cubed. 0x squared minus 0x squared is just nothing. We'll just leave it. Okay, here now we're getting instead negative 4x minus 1x. So negative 4 minus 1 is negative 5, right? So this is negative 5x. Now 0 minus negative 3. Just look at it. 0 minus negative 3. Two negatives make a positive, so that's 0 plus 3 equals 3. Plus 3. So what have we got? G minus f equals x cubed minus 5x plus 3. And now what they want to do is they want us to evaluate it at negative 4x. Okay, so what we're going to do here is say g minus f of negative 4x equals, open parentheses, negative 4x, close parentheses, cubed, minus 5, open parentheses, negative 4x, close parentheses, plus 3. Okay, now this is where it really gets important that we have a little bit of side work going on, ladies and gentlemen. So over here I've got negative 4x cubed, and we have to apply the power rule of exponents. Okay, man. So remember, this has an exponent of 1, and so does that. We're going to distribute, multiply that 3 to both those exponents. So here's what we've really got. We have, open parentheses, negative 4 raised to the power of 3 times, open parentheses, x, close parentheses, raised to the power of 3, equals, now, 4 times 4 times 4 is 64, right? Because that's 16 times 4 is 64. But you got negative sign, negative, negative, negative. There are 3 negatives. So since there are an odd number of negatives, the result is going to be negative, negative 64. Okay? X cubed. So we're going to write negative 64x cubed. Now we're multiplying negative 5 times negative 4x, and that's going to give us positive 20x plus 3. Ladies and gentlemen, guess what? We're done. g minus f of negative 4x equals negative 64x cubed plus 20x plus 3. Red box of correctness coming up. Right here. Done. Moving on. Moving on. Number 11. Okay, so here we're actually going to substitute in an operation x minus 1, which is really cool. It's more interesting than just evaluating. So what do they want? First we add the functions together, and then we evaluate at this algebraic expression. So you guys know what I'm going to do already. We're going to rewrite these like this. Okay, this is, see, they've really got you messed up here. So they got the negative x right there, which should really be up here, plus 4. They're really trying to mess with you, folks. So here we got negative 4x plus 1. And then you've got negative 1x plus 4. Hey, I'm telling you, I'm trying to get you. They're trying to get you. Don't let them get you. Now, what are we doing here? We're adding. Okay, so life is very easy. So we're just adding. All right, so blah, 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 blah. You can see I'm getting lazy. Okay, negative 4x plus negative 1x. Negative 4 plus negative 1 is the same thing as negative 4 minus 1 equals negative 5. So negative 5x. And then 1 plus 4 is plus 5. So h plus g equals negative 5x plus 5. But now we're going to evaluate that, h plus g, at x minus 1. So everywhere we see an x, we're going to put x minus 1 equals negative 5, open parentheses, x minus 1. I see the distributive property coming, plus 5. So we're just going to do the distributive property here and say h plus g of x minus 1 equals negative 5x plus 5 equals negative 5x plus 10. Now, this might be the way they want you to answer it, but could you factor out a negative 5? Yes, you could. I don't know if that's what they want, so I'll show you both ways. So that's possibly the answer. I have no idea what they want at this school. I just started working here. So what we could do, so I'm going to leave that as an answer. So here's an alternative answer. Okay, alternative equivalent answer. Right? So I have no idea if that's what they want, but let me just show you something. So you got negative 5x, right? Plus 10. Just think about this. You could divide both of these by negative 5 and reverse distribute that negative 5 out. That's called factoring out the greatest common factor. So you could have, as an alternative answer, you could have h plus g of x minus 1 equal to negative 5, open parentheses, x minus 2. Okay, so these two answers are equivalent to one another. So that's what I mean when I'm talking about greatest common factor. I don't know what what is the, like, what's the deal here at the school, but when I grew up, if there was a possibility of factoring out a negative and I didn't do it, that would be wrong, right? So this is answer 1, this is answer 2, I don't know. No idea. Okay, what was that, number 11? Number 12, 13. What's going on here? Okay, I think I see what's going on here. First, we're going to multiply so we're basically going to turn into a quadratic. Okay. So first, we're going to multiply the two functions, and then we're going to evaluate that at an algebraic expression. So number 12, this is going to be kind of complex. Not hard. Fun, right? That's how we look at it in pre-AP. Nothing is hard. It's just fun. So what does this mean? I mean, I think what it means is they want us to do this. They want us to say 3n plus 1 times 4n plus 2. I think that's what they want us to do. And then we're going to use FOIL, right? First times first, right? Outer times outer, inner times inner, last times last. Okay, F O I L. Right? Now, 3n times 4n is 12n squared. And then it's outer, so 3n times 2 plus 6n. Then it's inner, 1 times 4n plus 4n. Then it's last, 1 times 2 plus 2. These terms in the middle are common, and they can be combined. So we're going to just say this is 12n squared plus 6 plus 4 is 10, 10n plus 2. So that means that f dot g equals that thing, okay? But now what do they want us to do? Now they want us to say f times g of n minus 1. Okay, so what is that going to equal? Well, we're just going to replace the n's with n minus 1. So we have here 12. Let me zoom out a little bit. 12, and then open parentheses, n minus 1, close parentheses, squared. That's going to be fun. Plus 10, open parentheses, n minus 1. Simple distribution will take care of that. Plus 2. All right, now let's focus in on this, because it's going to be the thing that gets you, okay? So what you're going to have to do here is say n minus 1 times n minus 1. Now, some of you know the trick on this, but if you don't know the trick, FOIL will help you, right? First, outer, inner, last. Okay? So n times n is n squared. Outer is n times negative 1, so minus 1n. Inner is negative 1 times n, so minus 1n. And then last is negative 1 times negative 1, which is plus 1. So the common terms here, negative 1 and negative 1, that's going to be negative 2n. So the result, okay, of this is n squared minus 2n plus 1. And the thing is, it's a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So if you didn't know the trick, you would just FOIL it out. So now we're going to put this here and multiply it by 12. So here we go again. This is long. F times g of n minus 1 equals 12. Open parentheses. N squared minus 2n plus 1, close parentheses, plus, now distribute, 10n minus 10 plus 2. Okay, well, now we got a distributive property thing going on here. So f times g of n minus 1 equals 12n squared minus 24n plus 12 plus 10n, and then negative 10 plus 2 is minus 8. Okay, let's look for some common terms. I find a negative 24n, and I find a plus 10n, and then I find another common term here with the integers, the plus 12 and the minus 8. So we'll go ahead there and combine those. All right? So finally, final answer, f times g of n minus 1 equals 12n squared, and then negative 24n plus 10n is negative 14n minus 14n, and then 12 minus 8 is plus 4. Final answer. Okay. All right, we're on number, what did we just do? Number 12? Okay, so number 13 is going to be the same type of problem. And I'm going to take a little break and then come back and pick up there on number 13. All right, ladies and gentlemen, so we are back. If anyone doubts my dedication to my students, take a look at the timestamp in the bottom right corner of the screen. By the way, I located the file containing 8 through 12. So, round of applause. It will be included in this video. We'll start with number 13, since that's where we left off. Let's go ahead and clip that out and try to work it out. Now, I should be able to work through these rather quickly, right? Because if you're supposed to do them on a test, it shouldn't take me 5 hours to do them in the review. But it takes longer in the review because I tend to explain things a little bit more. So let's look at number 13. What are we being asked to do? First, we're being asked to multiply the two functions together using FOIL, and then we're being asked to evaluate that resulting product function at x minus 2. So let's get to work. 2x minus 4 times 3x plus 3. Again, we'll use FOIL here. First, outer, inner, last. Okay? Remember FOIL. Okay, so first times first, that's 2x times 3x, that's 6x squared. Outer, 2x times 3 is plus 6x. Inner, negative 4 times 3x is minus 12x. And last, negative 4 times 3 is minus 12. Notice that we can combine the middle terms. You always can. So we have 6x squared, and then 6x minus 12x is negative 6x minus 12. Okay. Now, the careful observer will notice that we could pull a negative 6 out of this entire algebraic expression, this quadratic expression here. You might ask, why would you pull a -6 out? Mostly because it's going to make the math a little bit easier. I could just pull a 6 out, so that's what I'll do. I'll pull a 6 out. So I'm just going to divide every term by 6, and what that results in is a kind of reverse distribution. It's called greatest common factoring. Okay, so it's a form of factoring. It's not factoring like you are used to with quadratics, but it's still factoring. So we have 6, open parentheses, x squared minus x minus 2. This is going to make the next part easier. Okay, so now we're going to evaluate. So what is this? This is f times g. Okay, so now we want to evaluate that at x minus 2. So we have f times g of x minus 2 equals 6, open parentheses, and then open parentheses, x minus 2, close parentheses squared, minus, open parentheses, x minus 2, minus 2. So leave the 6 alone for a second. 6, open parentheses, and now we're going to do this thing. Remember, the trick was going to be a squared minus 2ab plus b squared. So this should, what this should equal, and we'll test it with FOIL, is x squared minus 4x plus 4. But we'll double check that, okay? So x squared minus x minus 2 times x minus 2. FOIL gives us x squared minus 2x minus 2x plus 4, which equals x squared minus 4x plus 4. It's like we thought, right? So we'll replace this with x squared minus 4x plus 4. I'm going to keep that in parentheses just for a minute. Now I've got to think about this minus. This is why I wanted to pull out a -6, because then it would have turned all these into pluses. But we're essentially multiplying a -1 into these two terms here. So let's do that. So we have -1 times x is negative x. -1 times -2 is positive 2 minus 2. Okay, now all these parentheses can, well, we don't want them to disappear just yet, but we'll do a secondary step. 6, open parentheses, x squared minus 4x plus 4 minus x plus 2 minus 2. There's some simplification that can be done. Oops, let me close the parentheses off. So these can disappear because 2 minus 2 is 0, and then I've got common terms, -4x and -x. That'll give me -5x. So this will equal 6, open parentheses, x squared minus 5x, and then plus 4, right? So now all that's left to do is distribute back that 6 here, here, and here. That gives me 6x squared minus 30x plus 24. Now again, we could have left it in this unfactored, or in this factored state. This will be correct, right? So this is the same. So our two answers are f times g of x minus 2, f times g of x minus 2, and these bottom two things are equivalent. Again, I keep repeating this, I don't know what the school wants from you. You know, whether they want you to leave it with the greatest common factor pulled out, or whether they want that blended in. So those are both equivalent answers, and to my eyes, the top answer is preferable, but I don't know what the Algebra 2 team yet is looking for. So I'll just give them both, and then as I learn, I'll convey that information to you. So that's number 13. And moving on, number 14. So this one's a little bit different. Let's look at number 14. So first, what they want us to do is evaluate g at 2x, and then evaluate h at 2x, and then multiply those resulting functions together. Okay? So we'll clip that out and get started. Okay, so simple enough. First, we'll evaluate g of 2x, and that will equal 4, open parentheses, 2x, close parentheses, plus 1. So that will equal 8x plus 1. Okay, so that's g of 2x. And then h of 2x equals negative 4, open parentheses, 2x, which equals negative 8x. So these are my two things I'm going to multiply together. So let's do that. That one's g of 2x times h of 2x, which is equal to, open parentheses, 8x plus 1, close parentheses, open parentheses, negative 8x. This is just a distributive property. Since it's a monomial in the second term, h of 2x is a monomial, we're just going to distribute that backwards like that. So g of 2x times h of 2x is equal to, what is that, negative 64 x squared minus 8x. So that's a valid answer, but what could we pull out? We could pull out a negative 8x, right? So the greatest common factor of those two terms is negative 8x. Divide both by negative 8x. You know, if this thing that I keep doing is mysterious to you, make sure to come and talk to me about it, because it's going to come up a lot. When we start having to do factoring by grouping, you're going to do this all the time. So that was a valid answer. But another valid answer, g of 2x times h of 2x equals negative 8x, open parentheses, 8x plus 1. Notice that is this. All right? So there's my two valid answers. I got g of 2x times h of 2x equals negative 64x squared minus 8x. So those are the two answers. They're equivalent to one another. One just has the greatest common factor pulled out. I hope I'm not introducing confusion by showing two answers to the same problem, but I mean they are mathematically identical. It just depends on what they want. All right, so that was number 14. Number 15. Oh, this is going to be fun because we're going to be substituting in some expressions that have pluses. It's going to be cool. All right, let's get to work on this guy. So first thing we're going to do is substitute every x in f of x with 4 plus b, and then substitute every x in g of x with 4 plus b, and then multiply the resulting evaluated functions together. So let us begin. So I'm going to do this. I guess we'll just do it longhand starting down here. So f of 4 plus b equals 3, open parentheses, 4 plus b. I want to be real careful here that we don't think that's a 6. Plus 2. Distributive property. That's a b, not a 6. So that's going to be 12 plus 3b plus 2. I have common terms here. So simplification, f of 4 plus b equals, remember, start with the thing with the letter, 3b plus 14. All right? Now, g of x. So g of 4 plus b equals, open parentheses, 4 plus b minus 2. We didn't need the parentheses there, so this is equal to 4 plus b minus 2. Combine like terms. 4 and negative 2 gives us 2. So again, g of 4 plus b equals, lead with the coefficient b and then plus 2. So now you have these two binomials. We're going to multiply them together, right? Because that's what it says to do. Down here it says we're going to do f of 4 plus b times g of 4 plus b. We already know what those two things are, so that's going to be equal to, open parentheses, 3b plus 14 times b plus 2. Here comes FOIL. First, outer, inner, last. I'll just take the opportunity here. if these lines are actually visually confusing you, I had a student show me something cool one time. She considered herself a poor math student. Well, I thought she was pretty smart. And she said that you can form a crescent moon to do FOIL. I'll show you that. So first times first, outer times outer, inner times inner, last times last. Especially if you use this cool ink, right, that looks like the universe. It forms like a crescent moon. So this is another way, if you don't like those lines, of remembering to do FOIL. Look at that. It's pretty cool. It's like an artistic interpretation. So anyway, we'll get to the work. All right. So first times first, that's going to be 3b times b, which is 3b squared. Outer, 3b times 2 plus 6b. Inner, 14 times b plus 14b. And last, 14 times 2 is 28 plus 28. You always be able to combine the middle terms. So this equals 3b squared. 20 plus 20b plus 28. Now think of all the factors of 3, 20, and 28. There's no common factors, so that's it. F of 4 plus b times g of 4 plus b equals this, and that's the only answer. There's no GCF. Done. That was number 15. Okay, number 16 and 17 are composition of functions. And so I want to come back and do those as a separate little vignette. All right, we're back. So composition of functions is much easier than it looks. This little open circle, it used to confuse me because I thought that it meant multiply, but it doesn't mean multiply. What it means is, well, it's better to show it, right? So, show me, don't tell me. There's a great phrase in education that says, see if I can remember it. It says something like, tell me and I'll forget. Show me and I'll remember. And then there's some, it's the final part is, teach me, show me, let me do it and I'll understand. So there's that part where you do it and then you understand. If I just tell you, you'll totally forget. If I show you, you might remember. But if I let you do it, you'll understand. So I hope that you're doing this along with me. I understand for the purposes of this test, you don't have time to do it, right? I don't know what I'm going to do with this review, if I'm going to let you use it on the test, if they're going to let me. Anyway, let's get to it and figure it out. So 16, composition of functions. What does it want us to do? So what it wants us to do is it wants us to composite together G and H. So if, let me write this out just one time. I'll write it out longhand. If G of A is 3a minus 5, and if H of A is 4a minus 3, then G of H of A is, think about this for a minute, 3 open parentheses 4a minus 3 minus 5. And if we distribute that 3, we find that g of h of a is 12a minus 9 minus 5, and that's negative 14. So g of h of a equals 12a minus 15, or 14, sorry. And the only thing we could factor out is a 2, right? So I could divide these two things by 2 and pull that 2 out. It might make the math a little easier. So back to the task, we could write this as g, open circle h, is 2, open parentheses, 6a minus 7, like that. And now they want us to evaluate this at negative 6. So we're going to g circle h of negative 6 equals 2, open parentheses, 6, open parentheses, negative 6, close parentheses, minus 7, close parentheses, equals 2, open parentheses, 6 times negative 6 is negative 36, minus 7. So before we distribute that 2, we'll just do this. It's basically an addition problem, 36 plus 7. This is 13. So forget. Yeah. So it's 43. And then we're going to multiply by 2, right? So times 2, 6, 8, 86. So I think that g, the composition of g and h evaluated at negative 6 is equal to 86. So it was an integer solution. Now we're moving on to number 17. There we go. So first, we're going to composite together the functions. I think this is going to give us a little bit more juicy material to work with here. Let's make sure we understand what we're doing, right? If f of x equals 2x plus 4 and g of x equals x squared minus 5, then the composition of f and g is equal to 2, open parentheses, x squared minus 5, close parentheses, plus 4. Okay? Just distributive property gives us 2x squared minus 10 plus 4. That gives us minus 6. So this is 2x squared minus 6. That's the composition of f and g. And now they wanted to evaluate it here at negative 1. So the composition of f and g evaluated at negative 1 is equal to 2, open parentheses, negative 1 squared minus 6. Well, negative 1 squared is just 1, so that's 2 minus 6, and 2 minus 6 is negative 4. So I want to make sure to write this. Composition of f and g at negative 1 equals 2 minus 6, so the composition of f and g at -1 equals -4. Not that bad. They're faster than some of the earlier problems. Okay, so let's look at number 18 now. This is kind of a different way of writing it. Let's copy this, figure out what they want us to do, and then do it. So what do they want us to do? They want us to substitute in h of a in everywhere there's an a in g of a, and then evaluate that resulting composite function at 4a. I think that's what they want us to do. So let's just write this out again, just in case it's unclear. If g of a is 2a squared minus 4a, and if h of a is a plus 4, then g of h is 2, open parentheses, a plus 4 squared minus 4, open parentheses, a plus 4. Right? Yeah. So order of operations, we're going to do this first. And this should be a squared plus 2ab plus b squared. So let's go up here, just make sure we got that right. I think that it's going to end up being a squared plus 2ab, which is, so 2 times a times 4 plus b squared, which is 16. So this is a squared plus 8a plus 16. But let's make sure, right? Let's make sure we're doing it right. A plus 4 times a plus 4. FOIL says a squared plus 4a plus 4a plus 16. A squared plus 8a plus 16. Okay, just making sure that our little trick was right. And then here, so let's go back. G of h equals 2, open parentheses, a squared plus 8a plus 16, close parentheses, minus 4, open parentheses, a plus 4. And now we're just going to do a bunch of distributive property here. Yeah. And then this gets distributed this. So g of h equals 2a squared plus 16a plus 32 minus 4a minus 16. Combining like terms here is going to help us a lot. What like terms do we have? We have here like terms, and then we have the constants. So let's simplify. G of h equals 2a squared. 16a minus 4a is plus 12a. And then 32 minus 16 is just 16 plus 16. And then they want us to evaluate it at 4a. Is there anything we can factor out? We could factor out a 2. Yeah, that's the greatest common factor. So let's factor out a 2. Makes the math easier. remember, that's a reverse distributive property. We're just pulling the 2 out. So g of h equals 2, open parentheses, a squared, get rid of those lines, a squared plus 6a plus 8. So now what we're going to do is we're going to evaluate g of h at 4a. So everywhere I see an a, I'm going to put a 4a equals 2, open parentheses, 4a, close parentheses, squared, plus 6, open parentheses, 4a, close parentheses, plus 8. And then close parentheses because there's still this 2 out here. Okay, you got to close off the parentheses. So inside here, we'll get to work. This is equal to 2, open parentheses. And now remember, there's a 1 there and a 1 there. You're going to distribute the 2. So what you've really got inside is open parentheses 4 squared times open parentheses a squared. We'll get to that. Plus, here this is just multiplied 24a plus 8. Close parentheses, because remember, this whole thing is still got to be multiplied by 2 because we pulled that 2 out. Let's keep going. 2, open parentheses, 4 squared is 16. A squared is a squared. So 16a squared plus 24a plus 8. Now see, I'm tempted to pull an 8 out of this, right? So let me show it both ways, because I don't know. So first let's distribute the 2 through the whole thing. This is g of h of 4a, g of h of 4a. So g of h of 4a equals 32a squared plus 48a plus 16. So that's one complete answer, right? But what if, but alt answer, right? Alternative answer. Let's go back to the step where we had g of h of 4a equals 2, open parentheses, 16a squared plus 24a plus 8. What if I factored out an 8? Right, that's the greatest common factor of all those terms in the trinomial inside the parentheses. Pull that out like this. Okay, I'm going to get rid of those lines because they get in the way. What I end up with is g of h of 4a equals 2 times 8. So that's outside the parentheses. Inside the parentheses, I've got 2a squared plus 3a plus 1. So now an alternative correct answer is g of h of 4a equals 16, open parentheses, 2a squared plus 3a plus 1. This would be my preference as an answer. So these are your two answers. G of h of 4a equals 32a squared plus 48a plus 16. Oh, come on. Those are your two answers. Those are identical. Where are we at? Number 19? Okay. I see some potentially confusing stuff coming on. So let's get to it. Number 19. Why is this shifted over here? This is weird. It's strange, right? Here, let me do this. Let me carve it like grab that and paste it here, and then go grab the other part so it's lined up better. Paste, and then I can kind of like that. That looks better to me. I don't know. I think it was probably typesetting error. So it wants us to do g of h at negative 2t. So the thinking is if g of t equals 2t minus 4 and h of t equals 3t squared plus 3, then g of h equals 2, open parentheses, 3t squared plus 3, close parentheses, minus 4. So g of h is 6t squared plus 6 minus 4. So g of h is 6t squared plus 2. Can factor out a 2. Right? So g of h equals 2, open parentheses, 3t squared plus 1. Okay. Now we're going to evaluate that. G of h of negative 2t equals 2, open parentheses, 3, open parentheses, negative 2t, close parentheses squared, plus 1, close parentheses. Remember, these are the big parentheses that the 2 will be distributed back into, or not. So, g of h of negative 2t equals 2, open parentheses, 3. Now we're going to deal with this. Okay, so let's deal with that over here. What we've really got here is negative 2 squared times t squared. So that's going to be 4t squared. All right? So 3, open parentheses, 4t squared plus 1. Close off the big parentheses. So g of h of negative 2t equals, we're still not ready to distribute this 2, open parentheses, okay, 3 times 4 is 12t squared, and then plus 1. I would leave it like that. But, you know, you could distribute the 2 back into the problem, so we'll just write down both answers since I'm a little unsure about what they want. This would be 24t t squared plus 2. Do you see how this and this are identical? Okay, we're just flying through these problems. So these are your two different ways of writing the same thing. There in number, what was it, number 20? Number 19. Okay, so now we're on to some easier stuff. We're just adding polynomials here. But the trick is going to be to line up the quadratic, the linear, and the constant terms. That's all. This is going to be silly. So let's grab number 20. Now some students will simply, did I copy it? There. Some students will simply say, all right, we can just get rid of all the parentheses and just combine all the like terms, okay? But there's another way to do it. There's some people have a hard time with that because it's a long thing to read. So some people want to stack add, right? Everything's being added. So let's stack add. This is how I would prefer to teach it. And I'm going to stack add and reorder. I'm going to put this guy here and this guy here. You'll see what I'm talking about. So it's quadratic term with the squared and then the linear term with the x plus 1x. You see I've added the 1 plus 2. Trying to avoid potential problems. And now the second thing, I'm going to start with the negative 3x squared and then plus 6x plus 1. Then down here I start with negative 6x squared plus 4x minus 5. You're allowed to reorder like that with no problems. And you're just adding, okay? We just want to make sure that when we add, we remember that those are negative. So these are in our columns, you know. You're basically doing it column by column. So it's 5 minus 3 minus 6. Well, negative 3 and negative 6 are negative 9. So negative 9 plus 5 is negative 4, right? So this is negative 4x squared. And then 1 plus 6 plus 4 is 11, so plus 11x. 2 plus 1 minus 5, that's 3, minus 5 is negative 2. So final answer is right there. There it is. We'll just put a box around it and move on. Number 21. And there was nothing to factor because the 11 was prime. Okay, number 21. Moving on to number 21. Okay. Now here, I've got a recommendation. Okay, I've got a recommendation. Here's my recommendation. We start by distributing these negative symbols through these terms. And then we turn it into an addition problem. Okay? Just trust me, it's going to make your life easier in the long term. So let's rewrite this. We got 6x squared plus 5x plus 4. And then I've got plus. Now distribute the negative symbol here, here, and here. And then here, here, and here. and we're going to make this into an addition problem, plus negative 4 plus 2x squared plus 8x plus negative 2x squared minus 8 minus 4x. Okay, so now it's an addition problem. Perfectly valid. Let's line up all of our terms and stack add. So 6x squared plus 5x plus 4. And then remember, quadratic term first, 2x squared plus 8x minus 4. And then negative 2x squared minus 4x minus 8. Okay, so now this is an addition problem. Life is much easier this way. Just keep these in parentheses so we don't mess up. Alright, so these cancel and these cancel. It's going to make life easier. So this is just 6x squared. Now what is 5 plus 8? 13 minus 4. 13 minus 4 is 9. So this is going to be plus 9x minus 8. We're done. There's nothing to factor out because 6, 9, and 8 have no common factors other than 1. Since the only factors of 9 are 3, and 3 is not a factor of 8. Box. Moving on. Number 22. Okay. This is another one of them subtraction problems that would be made or rendered much simpler if we were to just distribute the negative signs and just turn the darn thing into an addition problem, which is exactly what we're going to do. So we're going to rewrite this as, and I'm going to just start by reordering these terms. Negative 7p squared minus 4p plus 4. And then here, distribute, 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 distribute. So that's one thing, right? Plus negative 4 plus 6p minus 7p squared plus, open parentheses, negative 3 plus 21p plus 9, or sorry, plus, what am I doing? I'm like distributing a 3. Sorry. So it's open parentheses minus 3 plus 7p plus 9p squared. Okay? So now we're going to stack add. I've got negative 7p squared minus 4p plus 4. And then carefully orienting my terms, I'm going to do minus 7p squared plus 6p minus 4. Those will cancel. These will not cancel, by the way, because we're adding. That'll be negative 14p. And then our final thing is positive 9p squared plus 7p minus 3. All right. Still easy. It's an addition problem. So remember, this is going to be negative 14p squared plus 9 gives us negative 5p p squared. Negative 4 plus 6 is positive 2, plus 7 is positive 9, plus 9p. And then those canceled, so it's just minus 3. Now, 5 and 3 are both prime. There's no factors here. We could pull out a negative 1, but why? Let's call it good. Number 23 is just FOIL. So is number 24, 25, and 26. So these are going to be super easy. Actually, let me let the processor on my computer relax for a minute, and I'll come right back and finish those up. All right, back at it. So we're going to do number 23 now. Sometimes with this Surface Pro 7, the processor starts to freak out. I hope that doesn't happen, because I'm using OBS. Some of you are YouTubers, use OBS before. It's very processor intensive. But I've got it rendering at 30 frames a second, ultra fast CPU settings, so it shouldn't be a problem. We're going to do FOIL here, first, outer, inner, last. And I will show the cool crescent moon, first, outer, inner, last. And I will color it in. Of course. Why not? Okay. I can't give the last name, but all credit goes to Michelle from Westwood High School. If she's watching, thank you for this. Okay, so I want to write it all out. I haven't done this yet, so I'll just write it all out. We're going to multiply 8b times b plus outer 8b times negative 3 plus inner 1 times b plus, that's a b, not a 6, plus last 1 times negative 3. Okay, so that's what we're doing. So this is 8b squared minus 24b plus 6 minus 3. So here we can fix that. This is going to be 8b squared minus 24b minus or plus 3, right? And we can't factor anything out, so we're done. Another student would say easy peasy lemon squeezy. So number 24. Go ahead and copy that. All right. Now this one is a binomial, n plus 2 multiplied by a trinomial, and the easiest way to do this is to use the geometric box method. So let's create a box. I don't want that box to be red. Stop, go away. Okay, now I want the ruler. We're going to create 2 rows, 3 columns. I don't know of a better way to do this where the chance of making a huge mistake is reduced. So this is 2m squared, and this is negative 1m, and this is negative 1. Notice I put that 1 right there. And then this is 1m, and then 2 plus positive 2. Okay, so now we're just going to fill in the boxes. So 1 times 2 is 2, m to the first, right, times m to the second is m cubed. Now 2m squared times 2 is going to be 4m squared. Now we have negative 1 times 1, which is negative 1. And then m to the first times m to the first is m to the 1 plus 1, or m squared. Notice these terms can be combined. And then we have 1m times negative 1, which is going to be negative 1m. Bottom row, negative 1m times positive 2 is going to be negative 2m. And then negative 1 times 2 is negative 2. Here's some more like terms. So we can combine the quadratics and the linears. So let's write this out, starting with the highest degree, 2m cubed. 4 minus 1 is 3, so this is plus 3m squared. Negative 2 plus negative 1 is negative 3m minus 2. Looking carefully, I don't see anything to factor, so that's the answer. Red box of correctness, right there. That's number 24. Number 25. Here's another binomial by a trinomial. My suggestion is to use the same box method we just used. So again, we're going to draw the box. It's going to be a rectangle, like that. The ruler, go ahead and make our columns. Column, 3 columns, 2 rows. Okay. Up on top, we'll put the trinomial 2a squared plus, well, and then we have 2a to the first, and then minus 3. Down here I've got 1a and negative 1. Okay, so 1a times 2a squared, so 1 times 2 is 2, a to the first times a to the second is a to the third. 2 times negative 1 is negative 2a squared. Here I've got 2a to the first times 1a to the first. That's going to be 2a to the 1 plus 1, which is 2a squared. And then 1a to the first times negative 3 is going to be negative 3a. Down here on the bottom, I've got 2a times negative 1, which is negative 2a. And then negative 3 times negative 1 is positive 3. Again, we could combine the quadratics and we can combine the linears. So this equals 2a cubed. These cancel, so there's no quadratic term left. And then negative 3 plus negative 2 is negative 5a plus 3. No common factors. It's finished. Very fast. That was number 25. And number 26 is just another binomial by a binomial. Shouldn't be too hard. FOIL method will take care of that. So first, outer, inner, last. I'll go back to this notation. First, outer, inner, last. Some people find that really confusing. FOIL. I'm just trying to show all the methods. So let's write it all out just so we know what we're doing. The first term is negative 5k times 2k plus outer negative 5k times negative 3 plus inner, that's 1 times 2k plus last 1 times negative 3. One thing I want you to notice is that every time I've got a negative, I always put the whole thing in parentheses just to avoid silly mistakes. Moving on, remember that you've got ones in your exponents here. It's going to be the product rule for exponents. Negative 5 times 2 is negative 10. K times k is k squared. Okay. So this is going to be a plus negative 5 times negative 3 is going to be positive 15. So we can put 15k and then plus 2k minus 3. The middle terms will combine, so we have negative 10k squared plus 17k minus 3. And here's where I want to just show that you could factor out a negative 1, right? It all depends on what you want to do with the answer, right? So that's one answer. So that this is like answer 1. Here's answer 2. These are going to be totally equivalent. So I'm just going to factor out a negative 1. So I'm going to pull a negative 1 out and just divide everything by negative 1. That gives me 10k squared minus 17k, just changes the signs, plus 3. Those are equivalent, you know. And as we get further and further in Algebra 2, you'll see why I keep doing this. You'll see why I keep doing this. This becomes really relevant. The ability to quickly factor out a greatest common factor is going to become super relevant. All right, that was number 26. Number 27. I got to be careful here because these are so easy that I tend to overcomplicate and I tend to make mistakes on these. So y'all pay close attention so I don't make any stupid mistakes. All it wants us to do, this is actually very simple, is look at the domain value of negative 5 and find the associated range value. In other words, look on the horizontal axis where it's negative 5, right here, and then go down until we hit the line right there, and then go to the right until we hit the y-axis at negative 6. So I think the answer is negative 6. Okay, so let's put that in a box. And y'all will tell me if I'm wrong. But I think that's all they want us to do. Stuff is really Algebra 1. What's going on here? Find the value of f of 6. All right. Well, let's deal with the internal part first. and then see what results. Oh, I think I know what's going to happen. So first we do this. So first, f of 6 equals, so let's find the domain value 6, go up, and then to the left, and we see it's 2. So that's going to equal 2. And so now f of 2, right? That would be f of 6. We're going to go to the domain value of 2, go down, hit the line, turn left, and it's -2. So I think the way we should write this, thus, or therefore, right? f of 6 equals -2. That's what I think. I'm going to go with it. I hear that processor in the background. The screen is getting hot. This makes me worried. There's only a couple left. Actually, there's just one left. So let's see if we can get it done. Then I think I'm going to combine all of these videos into one big video. And I think I've got enough time to render it all out in Camtasia and export to MP4, then upload to YouTube as a single video, maybe add timestamps. I don't know if I've got all that kind of time. It's 5:47. Then I still have to eat something, take a shower, and like drive to work, blah, blah, blah. Okay, let's see. F of G of 5. So, step 1. G of 5. So we're going to look at this graph here. So let's go to 5. Let's go down and then to the left. That looks like a -3 to me. G of 5 equals -3. So f of G of 5, so step 2, we're really doing f of -3. So here on this graph, right, we're going to go to -3, up, and to the right, and hit 2. So we can say therefore, there's our symbol for therefore, or thus, f of G of 5 equals 2. Okay. Perfect timing. I can sense the computer is completely jacked. All right, so we've completed the review. Thank you guys so much for watching.